Hi, this is Ken Stafford. I'm going to be going through June 2023 Foundation Paper 3 from Edexcel. I'm going to be working on one of my hint papers, which is basically the exam paper where I've highlighted some of the key bits of information and also written a few things at certain places that can help you. It's also going to help me do this paper. So you can see a few things I've highlighted here. So let's go straight into question 1. Write the number 3,107 in figures. So we're literally just converting the words into numbers to 3,107. Question 2, write 3 out of 10 as a percentage. You can use the calculator to help you. I mean, without a calculator, I would be thinking if I make it 30 out of 100, well, percent means out of 100, so straight away it's 30%. But you can type it into your calculator. 3/10 push SD, or however you get your decimal nowadays, it might be format decimal, and 0.3, and then to get that as a percentage, you times by 100. So 3/10 is 30%. Let's just scroll down. Question 3, we're just simplifying, collecting up the like terms. There are 1, 2, 3, 4 m's, and we're adding them together, which means we end up with m times 4. Or 4m. Not m to the power of 4, that would be if we were multiplying them. Question 4, change 4,000 grams into kilograms. So what you need to know for this is that 1 kilogram, 1 kg, is 1,000 grams. The kilo means 1,000. Okay, so 4,000 grams will be 4 kilograms. And then question 5, we're just going to put these numbers in order of size, starting with the smallest number. So the smallest number, when you've got negatives, got 2 that are negative here, -5 and -2. The bigger number, as in 5 is bigger than 2, is the more negative, because they're negative. -5 is smaller than -2. And then after that, we should feel fairly confident with the positive numbers. We've got 3, 7, and 9. Okay, so probably the only thing to watch out for there is ordering negative numbers. -5 is the most negative, so it's the smallest. Question 6, being asked to find the area of this shape. And I've highlighted area and I've written the word squares. So area is how many squares are in a shape. Now, normally we can't see them, but in this question we can. So we could quickly count them. Obviously, we could have figured out there are 12 squares in this rectangle because it's a 2x6 rectangle. And also we've got these extra 2 here. So there's 14 squares, 14 centimetre squares to be exact. And that's shown here on the answer line, so we don't have to write that. And then the perimeter of the shape. So the perimeter of any shape is just all the sides added together. So that is 2 centimetres long. Got 4 centimetres long. 1, 2, 3, and 6. So we're just going to add all of these together, and they should add up to 18. So the perimeter of the shape is 18 centimetres. No need for any working out there. You can show it if you want to, but it's only worth 1 mark, so the answer will be enough. Question 7, again, I've highlighted what it wants us to find. The probability that the spinner will land on a 2. Well, 2 of the outcomes, 2 of the numbers on the spinner out of the 4 are 2s. So half of them are 2s, and half is described as an evens chance. So that is the answer. I should put that on the answer line as well. And then choose the word that describes the probability that the spinner lands on a number less than 4. Well, if you look, all the numbers less than 4, they're all either 1, 2, or 3. So it's certain to get a number less than 4. It's definitely going to happen. And then I don't need to have the top in, so I'll zoom in on this. Ralph rolls a biased dice once. The probability of getting number 5 is 0.4. Work out the probability that Ralph does not get the number 5. Well, he's either going to get the number 5 or not. So if the probability of a 5 is 0.4, the probability of not getting a 5 must be 0.6. And the reason for that is that these two probabilities, because they're the only possible things. You're either getting a 5 or not getting a 5. They must add up to 1. And we could write 1 take away 0.4 is 0.6. It's good to do that. I mean, there's no working out marks here, but why not put it? Why not be in the habit of it? Doesn't hurt at all. Question 8, we've got a quadrilateral that has 4 right angles and 4 sides of equal length. What's the name of this shape? So 4 sides of equal length, which I can indicate that they're equal with these hatchings, and 4 right angles. Well, I think we all know what this is. It's a square. And then what's the name of this mathematical shape? It's kind of a box shape. It's a cuboid. If all the faces were squares, it would be a cube, but it's a cuboid. Question 9. We have got the number of books read by 4 people in 1 month. Again, this is my hints paper. So I put here the total. If we added them up, there are 22 books that have been read in a month. That is what all 4 of these people have read. The median number of books, well, if we put this in order, Kezia read 1, Tabby read 5, not 2, Eximina, not sure how it's that, 7, and then Martha 9. So the median means the middle. So because we've got 4 numbers, there is no number in the middle, but we go for the number equally in between 5 and 7, which is 6. The range is the difference between the largest and the smallest. So in this case, Martha read 9, Kezia only read 1, so it's the difference between these 2 numbers. So an 8 difference between whoever read the most and whoever read the least. And now we're going to put all of this into a bar chart. So again, on this hint paper, I've put the scale on. I've written that the number of books is on the y-axis, and I've put the names of each people on the x-axis. These bars we're about to draw for the bar chart need to be equally spaced, and they need to be the same width. If we manage that, we can literally just draw it up to the height. So Kezia to there. Martha was 9, so she goes to there. 1, and then 5. So we need to label all the axes. We need to draw bars that are equally spaced, not touching each other, and equal widths, all the same widths. And again, here I've gone to a bit of effort here, highlighting and sort of taking from the wording at the top, kind of what's happening. Wayne starts walking at 8:30 a.m., which we're told up here, and he walks for 1 hour and 45 minutes. So we can figure out what time he stops. So we're going to add on 1 hour and 45. So you can use your calculator for this. I'm going to show you how you do it on the calculator as well. How you add time together on the calculator, you use the time button. Without a calculator, I'd be thinking, well, half an hour to get till 9 a.m. plus an extra 15 minutes from the 45, so that's 9:15, plus the hour, that's 10:15. 15-minute rest, so 10:30, because we add on 15 to the 15. And then an 85-minute walk to the cafe. We could think of an 85-minute walk as 1 hour, 25 minutes. So if we add on the 25 minutes, we get 10:55. Add on the hour, we get 11:55 a.m. So he reaches the cafe at 11:55. Does Wayne get to the cafe before 12 noon? Yes, 12 noon would be 5 minutes later. So we need to say yes. And we could say he gets there at 11:55. Ooh. So as you've got a calculator, it's really useful to learn how to use the time button. And again, I'll show you that the calculator's on the right, show you how you can use it. And I also talk through how you can do it without using the calculator. And then we've got question 11. Gabriel thinks of a number, which is x. That's what we use for an unknown number. He multiplies his number by 5. Well, if you times x by 5, you get 5x. And then he adds 7. And the answer, what it equals, is 72. So what I've done there is taken the words and formed an equation, which we can now solve. To solve it, we need to figure out what x is. And the first step here will be to figure out what is 5x. Like, if we don't add 7 onto it, it's not going to be as much as 72, is it? And the method here is the balance method. To get rid of plus 7, we take away 7 from the left. You can write these steps. I don't tend to, but I will today. 72 take away 7 is 65. And then to figure out what 1x is, if you've got 5 of them, well, you divide by 5. It's called the unitary method. You divide by however many you've got. And 5 goes into 65 13 times. So Gabriel thought of the number 13. How could we check this? Well, we could put it back in. We could do 13 times 5 is 65. Add on 7, and we do get 72. It kind of feels pointless when you've got the right answer, but that's what we're looking for. Putting your number back in when you solve an equation. If you just get what you started with, then you know you've done it right. And if it feels pointless because you just got what you worked out, well, that's a good thing. You've got the marks. Okay, we've got a pie chart here for question 12. Write down the modal grade. So mode means most. So most people got a merit. How do I know that? Well, it's to do with the angles. 150 was the biggest angle, so it represents the most amount of people. It was bigger than 105, it was bigger than 75, it was bigger than 30. Most people got a merit. It's the biggest section of the pie chart. And then we're told 7 students got a distinction. And we know that those 7 students have an angle of 105 degrees. So to figure out the angle for one student, we would divide by 7. Again, we're using the unitary method. 105 divided by 7 is 15 degrees. So that's the angle for one student. Now we need the total number of students who took the guitar exam. Well, the total is all the way around the whole term. It'd be the whole 360 degrees in the middle of the pie chart. The whole way around here is 360 degrees. So how do we get from 15 degrees to 360? What do we multiply by? Now we can figure that out by dividing 360 by 15. That division will tell us exactly what we need to do, and that is 24. So that's what we would need to times 15 degrees by to get to 360. So that's what we times one student by. So it must be 24 students. So 24 students took the guitar exam. That's our answer. Question 13, we've got a travel graph, distance time graph. And these, I just want to say as well, I will be uploading the solutions. They're on my website. I'll also put a link to the solutions, like these hand-drawn solutions as a PDF, in the YouTube video as well, in the description if you want to see them. It's always useful to have a look at these sort of handwritten solutions, perhaps before looking at the video. It's maybe a bit quicker. And then if the handwritten solutions don't work, watch the video. It's always a good bit of advice I give to my students. Really tempting on these type of questions to feel like someone's going uphill. That's not what's going on here. It's the distance from home. So Rowena starts at home here because the distance from home is 0. And she's traveling away from home. She's on her way to the beach, but she stopped at the cafe on her way to the beach, and a stop is like a flat bit. And I've highlighted that in red. She stops here. This is the cafe. And how many minutes did Rowena take to drive to the cafe? Well, time is running along the x-axis. So she gets to the cafe at 12:30, and if she left at 12, well, that's 30 minutes. And what distance is Rowena's home to the cafe? Well, the cafe is 10 miles from her home. Okay, just going to scroll onto the other page to have a look at part C. So she stayed at the beach for an hour and a half. So we've got to put this onto the diagram. And remember, a stay is a horizontal line, a flat line across. And then she drove home without stopping, and she gets home at 4 o'clock. So we've got an hour and a half stay at the beach, and then she gets home at 4 o'clock or 1600. So she gets to the beach at 1:30. An hour and a half later will be 3 o'clock. So this is the time she's at the beach. So I need to draw a straight line across. You don't need to write this, but I'm going to put it there. And then she gets home at 4. So what I need to do is just connect up this with this. I don't have a ruler to hand, so I'm just going to hand draw my line. Use a ruler for that if you can. I mean, you won't lose the mark if you don't, but definitely do it. And that's that. So she did that journey, the 35-mile journey, in an hour. Okay. So we've completed the travel graph. That's done. The speed for the journey from the beach to Rowena's house. So as I said, it was 35 miles and she did it in an hour. So 35 miles in 1 hour. Well, that is 35 miles an hour. Feels a bit simple, but it's 1 mark. So we should feel okay about that. If it was 3 marks, I'd start thinking, have I done this right? But 1 mark, that's pretty good. Question 14. Again, I've come ahead here and sort of written a few things on. This is about boxes and bags. So 120 boxes cost £6 and 270 bags cost £10. So I've started off by saying, well, £6 is 600 pence. I feel like we should convert into pence because we're working out the cost of 1 bag and the cost of 1 box. So they're going to be in pence rather than pounds. So I'm going to convert also £10 into pennies. So we times by 100 because there's 100 pence in a pound. So 10 times 100 is 1,000. So I can say 270 bags is 1,000 pence. So a bag is cheaper than a box. It tells us that. How much cheaper? So, well, to compare them, we need to know what 1 box is and what 1 bag is. So how do we figure out what 1 box is? Well, because there's 120 boxes, we use the unitary method, which means we divide by 120. So we're going to divide 600 pence by 120, and that is 5p. 1 box is 5p. I'm going to do the same for the bags. So divide by 270 because there's 270 bags, and we're going to divide 1,000 by 270. Now, 270 is not going to go in nicely, but it does say give your answer in pence correct to 1 decimal place. So we get 3.7p. 3.703, and the 7, the 0, and the 3 recur, but that is 3.7 pence. And then we always need to go back and read the final line or the line above. How much cheaper? We need to figure out the difference between them. Well, it's the difference between 5p and 3.7p. And 5 take away 3.7 is 1.3 pence. So that is the difference between the box and the bag. And 4 marks, we've shown all the stages. We've definitely got the method marks for this, and we've got the right answer. So we should feel good about it. Question 15, we've got a ratio question. Again, I've sort of taken this information from the question and sort of put it down beneath. Number of red bags to the number of green bags is in the ratio 1 to 4. If there are beads, if there are 35 beads in the bag, work out the total number of beads in the bag. Well, there's 4 times as many green as red. So we need to multiply 35 times 4, which is 140. And the total number of beads in the bag will now be the 35 plus the 140. So there must be 175 bags and beads in the bag. Quite simple, but 2 marks. So again, we can feel like that wasn't we haven't done it wrong. We didn't have to do a lot of work for those 2 marks. If it was worth 5 marks, I'd be thinking, have I done it right there? Have I done enough work? Question 16, describe fully the single transformation that maps shape A onto shape B. So we're going from A, which has been highlighted in red, onto B. Now there are 4 transformations. We have rotation, reflection, translation, and enlargement. It's not been reflected. It's not been translated because it would still be the same way around. A translation would give you a shape like this. It's like sliding it. So obviously we can see shape B has been turned, which can happen through some of the other transformations. A reflection, that's definitely not happened. If it was reflected, it might look something like this, or potentially like this. Again, it's not that. It's a rotation. And you should always have tracing paper in the exam if you're doing this at home, which you probably are, otherwise you wouldn't be watching this video. You maybe don't have any tracing paper. You can use those plastic sleeves that you can put documents in and write on them in biro. That works quite well if you don't have tracing paper. And the way to do this is you've got to kind of guess where the center of rotation is. I would put my tracing paper on if I had it and draw this shape and then sort of guess where the center of rotation is. Generally, it's either the origin or somewhere near, and it is the origin in this case, and you can start to see them by this and then turned sort of like this to get that point. And to go from A to B, it is a rotation and even 90 degrees anti-clockwise. So this is anti-clockwise. Or you could go clockwise. If you went clockwise, it would be 270 degrees. So you've got a choice there. But what you need to put is you need to put rotation. You need to give the center of rotation 0, 0. Or you could say the origin. And you need to give the angle always and the direction. So if it was 180 degrees, which is a half turn, the direction isn't that important. So 90 degrees anti-clockwise or 270 degrees clockwise. You've got choices there. I have got lots of worksheets on my website, like practicing transformations. It's generally something in my experience of teaching people that they don't feel confident with. It's quite a hard one to teach to a class. So coming and looking at those worksheets could be useful. Hit me up in the comments if you can't find the worksheets on my website. And then question 17. We have got bearings, and talking about topics that people don't like, bearings is probably up there as the number one when I work with people that people don't get and don't enjoy. Let's have a look at this. So town R is 55 kilometers from town T. So town T is what's marked on here. So on a bearing of 65 degrees. So bearings are just a way of giving direction using angles. They're more accurate than using words like northeast, south, west, stuff like that. So you need to know how to use a protractor to do this question. Obviously, you can't see my protractor. I'm doing this on a screen. If you're not good with a protractor, you should look up a video on how you use a protractor. This isn't really the time or place to sort of teach you how to use a protractor, but I've marked that 65 degree angle on. And if you followed from town T along this orange line, you are heading on a bearing of 65 degrees, sort of northeasterly. Okay. And then we need to mark where town R is with a cross. Now the scale is 1 centimeter to 10 kilometers. So 55 kilometers is 5.5 times longer. So it's going to be 5.5 centimeters along the line. Now I'm doing this on the screen, and you potentially are doing this on a paper that's been printed for you and might not be 100% accurate depending on the size of the paper. Sometimes it's 2 pages per sheet of A4, but I would measure 5.5 centimeters this way and put my cross, and then it says Town R with a cross. I'd also put the R there as well. If you're, and I've quickly whizzed through that, it's a good thing to go away and maybe find more videos on bearings if it's not something you understand. Okay, question 18. So there's a bad saying in maths teaching, if in doubt, expand the brackets. We don't actually have to expand the brackets here, but it probably makes sense to. I'll show you why you don't have to expand the brackets as the second part of this. But just to make this equation a bit simpler, we're going to expand the bracket and times everything in the brackets by 4. So 4 times 2 is 8. 4 times 2x is 8x. 4 times 3 is 12, and there was a minus before the 3, and it remains. So we would get a mark for doing that straight off. If we did nothing else, we got 1 mark here. We've got to solve it, so we need to get rid of the minus 12 on the left. We need to get 8x on its own. And ultimately, we need to get x on its own. Once we get x on its own, that's what the question wants. To get rid of that minus 12 from the left, you do the opposite. So you add 12. 20 add 12 is 32. And then to figure out what 1x is, again, and we've used this quite a few times in this video, you use the unitary method, which is to divide by however many you've got. So we divide 32 by 8 to get 4. Okay. I said at the start, you didn't necessarily need to expand the bracket. What you can do at the start is get rid of the 4 by dividing both sides by 4. So if you divide the left by 4, you no longer need to multiply what's in the bracket by 4, but you have to do the same to the other side. So we've got to divide the 20 by 4. It becomes 5. Now to get rid of minus 3, we add 3, and we get 2x equals 8. And then the final step to figure out what x is, we divide by 2 because there's 2 of them, and we also get x equals 4. Probably the quicker way of doing it, but doing the first way is probably what, for a lot of you, makes the most sense and probably what you'll do. Question 19, we've got a question about interest. Now there are 2 types of interest questions. One is simple interest and one is compound interest. And this is a simple interest question. So simple interest is when you get the same amount of money paid to you as interest each year. So if it's £100 in the first year, it'll be £100 in the second year, and so on. Compound interest is when you get interest paid into a bank account, say. So when you get interest in the second year, because there's now more money in there, the actual amount of interest you get paid is slightly more the year after, and more the year after that, and that's the compounding element. So what we can take from this is, if Jenny got £450 in interest over the 6 years, she got the same amount each year. So again, using the unitary method, you'd be surprised how often you use this, how much it can make sense, just direct proportion. We're going to divide that £450 by 6 to figure out what does she get each year. So each year it was £75 in interest. So from this we can work out the interest rate, because she was getting £75 based on her £3,000 that she originally invested. So if we type this into the calculator, it will figure out what the percentage is as a decimal, and it will straight away simplify the fraction to 1/40th. But again, if we convert it to a decimal, we get 0.025. To get it as a percentage, we always times by 100. To go from decimal to percentage, we times by 100. So she must have been getting an interest rate of 2.5%. So why is 2.5? Because 2.5% of 3,000 is £75. And we can check that on the calculator by doing 2.5% times 3,000. That is 75. So we can check that we've done this right. Question 20, we've got some algebra. These are the kind of questions when you first start learning them that you maybe hate, but after enough times of doing them, you maybe look forward to, because you just learned the rules and these are easy marks. So we should get used to the fact that when there's brackets here, we times the 2 and the 3 together. 2 times 3 is 6, so it's m to the power of 6. These would have been probably the first ones you were taught. When we times x's together in this case, we add the powers because it's 5x's being times together multiplied by another 8x's. So overall, you end up with 13x's being multiplied together. So we add the powers. And then doing this expansion here, 4p times p squared. Well, p times p squared, let's zoom in on this. Again, we're adding the powers. There's a hidden 1 there. So 1 add 2 is 3. And because of the 4, we also times p cubed by 4. So we get 4p cubed. And then we're going to do 4p times 3p. So p times p is p squared. And 4 times 3 is 12. And there was a plus symbol here, so we just put it in there. So our answer is 4p cubed plus 12p squared. Just going to put that on my answer line. Doesn't matter if you don't really, but you should always really do it because that's where the examiner is going to look straight away. And if they see the correct answer there, they're going to straight away give you the 2 marks without having to worry about working out or anything like that. They'll probably just give it to you straight away. So always put it there. Then question 21. So a lot of information here. These highlighted worksheets or exam papers, hint papers will help you. And if you struggle to sort of read these type of questions and understand what to do, having a go at my hint papers will hopefully help you. And maybe you can start to use a highlighter in the exam. Having a few different colors, I think, is key as well. Otherwise, people just end up highlighting everything and it doesn't really help. So we need to know, Johnny wants to know how much coffee he will need for 800 people at a meeting. So each person who drinks coffee will drink 2 cups of coffee. So I've put that here. One person who drinks coffee will have 2 cups. And then 10.6 grams of coffee is needed for each cup of coffee. Okay, we'll come back to that. Now, Johnny's assuming 68% of the people will drink coffee. So if we figure out 68% of the 800 people, I can see here I put 600 there. Let's change that to 800. I'll have to change the hint worksheet as well. So 68%. So you can type it in as 0.68 times 800, or you can use the percentage button and do 68% times 800. 544 people are having coffee. Okay. So we can put that 544 here. And we know each person has 2 cups. So straight up we can say, right, well, how many cups of coffee if 544 people are having coffee? That is 1,088 cups. Okay. So we now figured out how many cups of coffee will be drunk at the meeting. And then the amount of coffee Johnny needs to buy. Well, it's 10.6 grams of coffee for 1 cup of coffee. So we're going to times 10.6 by the number of cups of coffee. And that ends up being 11532.8 grams. So I'm going to put grams for now. Oh, and actually it wants your answer correct to the nearest gram. I was wondering if it would want us to go into kilograms. So to the nearest gram, we're going to use the rules of rounding, and the 8 is going to make the decision here for us. 5 or more, we go up. So the amount of coffee needed is 11,533 grams, because it's closer to the 3 than the 2. Johnny's assumption is wrong. So 72% of the people will drink coffee. How does this affect our answer? Well, we work this out on 68%. So if more people are drinking coffee, he will need more coffee. So that's what they want to see here. There's only 1 mark. We don't need to work anything out. We don't need to work out how much coffee is needed for 72%. We just now know that he will need more coffee than what we worked out. Okay, Again, I've come ahead and highlighted some sort of element to this question. We're told about the parallel lines, so that's really key to this. This is the marking for parallel, but we're also, and that's what this is telling us. So to an extent, you can read that and take something from it, but if you know what those markings mean, you don't really need to read that bit. You should read it just in case, but it's kind of visually there. And we need to show that triangle ACD is isosceles. So triangle ACD is this. It's indicated by the three letters A, C, and D. So if it's isosceles, what we need to know about that is that two of the angles will be the same. So two angles are the same as each other. If all three were the same, it would be an equilateral. So looking at it, it kind of looks like the blue and the purple angles are going to be the same, but these questions are never accurately drawn, but it doesn't hurt to think about it like that. So straight off, we need to be thinking, well, what angles do we know? Now, you might notice two of the angles are marked in green. That is because they are corresponding angles. Those angles are the same as each other. And we can figure out what this angle here is. We can figure out what angle CFG is. It is whatever 125 is when you take it away from 180. So it's 180, take away 125, which is 55 degrees. Now we've got to give a reason. The reason here is angles on a straight line sum to 180 or add up to 180. So that's our first angle we found. And I'm going to put that on here, and actually I'm going to put it there. So I'm now going to say ACD equals angle CFG, which equals 55, because they are corresponding angles, because corresponding angles are equal. Because of the parallel lines, those two are corresponding. And we've now found one of the angles in CAD. Okay. If we come back up here, we could find this sort of pinky purple angle. It is 70. The reason we know this is ADC equals 70. Again, angles on a straight line sum to 180. We know the one on the other side on the straight line is 110. And now we know two of the angles in triangle CAD, so we can figure out this blue angle, the final angle. Let's make that a bit thicker. Angle CAD, I'm just going to write it down here. CAD equals 55. And that is because angles in a triangle sum to 180. Because 55 add 70 makes our 180. And then final step, I suppose, is our sort of, we say, and I thought it would be the blue and the purple, but actually it's the blue and the green. We say DAC equals ACD, and they're both 55. So triangle ACD is isosceles. And that's our overall sort of answer. Might come back and tidy this up a little bit for the solution paper. So I'll be uploading these handwritten solutions. There'll be a link in the description. So if you want to just have a look at these like that, that's perfectly fine. Question 23. And this is interesting because we've done a lot of direct proportion in this paper, a lot of thinking about what you do when you know 5 of something, how do you find 1? Now we need to be aware of these questions. They come up a lot. This like filling up with a pump, or painters painting a house, workers doing something, machines doing something. This is an inverse proportion relationship. which is less common and makes less sense to us as humans. But if we think about it in the right way, it does make sense. So we're told that 5 pumps will take 14 hours to fill a water tank. Now, what we've done each time is, if you've been watching the whole video, to find out what 1 pump is, you divide by 5. So you do the same over here. That's not going to work this time, because if you've got 5 pumps working and they take 14 hours, if you drop down to 1 pump, it's going to take longer. So actually what we need to do here is the inverse, which is to times by 5. We're going to have to times 14 by 5. So it's actually going to take 70 hours if only 1 pump's working. It's going to take longer. We've no longer got 5 pumps, we've only got 1, so it takes longer. And then to figure out how long 4 pumps will take, well, that's 4 times as many pumps. So it's going to be 4 times quicker. We can divide the time by 4. So 70 divided by 4, we get a decimal, but it's not a horrible decimal. We can feel okay about this. 17.5 hours for 4 pumps. So a bit longer than 5 pumps, which makes sense. It should take a little bit longer if there's less pumps working. Question 24, we're trying to find the highest common factor and lowest common multiple of numbers A and B. Now, we don't know what A is and we don't know what B is, and we could figure them out on our calculator if we wanted to, but we don't really need to. One of the ways of doing the highest common factor and lowest common multiple is you do the product of prime factors and you put them into a Venn diagram. And because these numbers are given to us as the product of prime factors, we can just put them straight into a Venn diagram. And we're looking for what's common to both. So there are no 2's in B, so I can put all the 2's, there's 2 of them, 2 squared over in A. There are 3's that are common to both. So A has got 4 3's, 3 to the power of 4, and B has got 2 3's. So I can put 2 in the middle, 2 are common to both. And the other 2 from A just stay over here. They're not common with B. And then we've got, just pick a nice colour. Actually, I don't want that colour. Let's go with pink. When we do the 7's, there's 1 7 in A and there are 2 7's in B. So the second one needs to go over there. And I've already highlighted the middle. That's what's common to both. That's the highest common factor. So we times those numbers together. So we do 3 times 3 times the 7, and we get 9 times 7, which is 63. So that is the highest common factor of both of these numbers. And then the lowest common multiple, we times the 3 sections together. So we do all of our 2's, so 2 times 2, all of our 3's. There's 2 in A, so we've done the A bit, but now we also do the bit in the middle. So what we could do, because we've already figured out that's 63, the middle section, let's just put that there. And then we're going to times by the final 7. So what we've done is we've times every number together to get the lowest common multiple. And that is 63 times 7, 15,876. So big number. Question 25. We've got a question about lava flowing from a volcano. So it's flowing at a constant rate of 11.9 meters cubed. So that's a volume per second. So, and I've just taken that and I've written 1 second equals 11.9 meters cubed. And it wants to know how many days it take for 67,205,600 meters cubed of lava to flow from the volcano. And we need to give it to the nearest day. So the way it made sense to me is, well, let's figure out how much lava in a minute. So in 60 seconds. So let's times this by 60. So 11.9 times 60 is 714 meters cubed. Okay. And then in an hour, which is 60 minutes. So again, we times by 60. So I'm going to times that 714 by 60. in an hour, there are 42,840 meters cubed of lava flowing out of the volcano. And then I thought, let's go to a day. So 24 hours. So we're going to times by 24. Once we times that by 24, we get 1,028,160 meters cubed of lava per day. So to figure out now how long it takes for 67,205, 600 for every day, well, we know every day it's 1,028,160. So we just do this division and we're going to figure out how many days it is. And it's telling us to give it to the nearest day, so we know it's not going to be a whole number. We're just going to have to use the rules of rounding. And as a decimal, I got 65.36. So 65 days. Okay, question 26 here. The turning point of the graph. So we've got a quadratic graph. We know that from the shape. We should know that from the fact that it's got an x squared and not an x cubed. So it's quadratic, meaning squared. The turning point, I feel like when I've done this with people who never been taught what a turning point is, they're like, well, it's probably that point at the bottom where the graph turns. And they're correct. So the coordinates are when x is 1 and when y is -3. Okay. Now the roots are where it crosses the x-axis. They're also known as solutions. And it's asking us for one of the roots. There are two. I'm reading the pink one as -0.7. And I'm going to give the other one, just because you might be looking at both, as 2.7. And I've already come ahead there. They'll accept any answer from -0.8 to -0.6, and likewise for the red one as well. So you've got a bit of leeway depending on how you read it. We don't all quite read it the same way. For question 27, you need to know the formula for density. It's not something that's given to you. I've put it here into the formula triangle. Worth bearing in mind, a lot of formulas are kind of given in the unit. So because we're told the density, it's telling us density is grams divided by centimeters cubed, or density is mass, because mass is weight, divided by the volume, which we're measured in centimeters cubed here. So as much as you're expected to learn these formulas, sometimes they are just there. They're given as part of the question. What I like about, I mean, some teachers don't like the formula triangle. I like it, particularly for questions like this. So a way of learning it, you've got to learn where to put letters. DMV, drink more Vimto. A student taught me that, but they didn't use Vimto. So we're going to use this triangle. I like to use it to figure out the mass. The idea is you put your finger on it, and then to get mass, because it's at the top, you times the 2 at the bottom. So you times the density, which we're told is 9, by the volume, which we're told is 72. And 9 times 72 is 648 grams. So we would expect this cuboid, which is made of a metal, 9 grams for every centimeter cubed, 9 times 72, because we got 72 centimeters cubed of it. 2 marks. Simple if you know the formula, or you can interpret the formula. Impossible if you don't know what it means, but quite easy marks at this part of the paper. We're on the penultimate question. If you know the formula, hopefully quite happy with that. And then on to 28, which is the final question. Again, we're going to use the unitary method here because we're given a ratio in standard form, and we need to make the red bit, the one on the left, the 9 times 10 to the 4, 1. So we need it in the form 1 to n. So in this case, what you need to do is divide this by something to make it 1. Well, if you've watched this video, I've probably done this about 8 times. Divide by 9 times 10 to the power of 4 will make it 1. So we're going to divide 4.5 times 10 to the power of 6 by 9 times 10 to the power of 4. Now, this is perfectly possible on your calculator. All you need to know is how to use the standard form button, which is, if you've got a Casio, it's in the middle at the bottom. And please do watch what I'm typing in, it'll be on the bottom right on your screen you're looking at. And we do this and we get 50. So it's in the ratio 1 to 50. On to the final part of the final question. We got to order these numbers, which aren't in standard form generally, apart from the red one. We can use our calculator here, so we can just type them straight into our calculator and get them as normal numbers. So 5.625 times 10 to the 4 is 56,250. No need to do anything with 5,625. And if this one becomes, the blue one becomes 56.25. And finally, we get 562.5 when we type that into a calculator. So hopefully now this is quite easy just to order them. Now, don't put 56.25 as the smallest. We need to give it as they were originally given. We should do. And then we are going 0.005625 times 10 to the 5. And then on to 5,625. And our biggest number, 5.625 times 10 to the 4. Lots of ways of doing that. But actually, if you've got a calculator, why not use it? And that is the final question. Hopefully that was useful. If I made any mistakes, which is more than possible, let me know in the comments. If you liked it, let me know in the comments. I will put in the description the link to the hint paper. So this is the same paper with my highlighted things and little clues. And I will also upload this as a PDF, these solutions as well, so you can have a look at them that way if you want. Lots more papers and worksheets on my website, kennethstafford.co.uk, if you want to have a look. And thank you for watching. Hopefully that was helpful.